Good day, everyone. We are the researchers, and I am Zane Alison V. Capelaran. With me are Roden R. Veligano and Sider J. Lagi. Our capstone project is entitled Smart Vision Application of Image Processing for Braille Text Interpretation and Display. This project will enable teachers to more efficiently, easily, and accessibly check Braille outputs of blind and low vision students. It allows real-time scanning or even uploading pictures of Braille for interpretation. Braille has been one of the most important modes for people who are either blind or have low vision. It aids them in reading and writing, but learning and sharing Braille still remains challenging, particularly in classroom settings. In SPED passing, for instance, students still use the traditional way of reading Braille, touching and feeling the raised dots. It's effective, but time and effort consuming, especially on the part of the teachers, having to check each output of each student by hand. Due to this, teachers find it difficult to give immediate feedback, which slows down the process of learning and thereby makes it difficult for students to make quick improvements. Statement of the problem. The goal of this study is to develop and answer the following research questions. The first statement of the problem is, what are the stages undertaken in the development of smart vision application of image processing for Braille text interpretation and display using agile methodology? Next, how can mobile applications and machine learning be integrated into the development of smart vision application of image processing for Braille text interpretation and display? Next, how can the system's design and features support both teachers and visually impaired students in classroom activities, particularly in relation to the SPED PASI curriculum's quarterly themes? And lastly, how accurate and efficient is the system in processing uploaded Braille images under varying conditions, such as lighting quality and image clarity? Before logging in, users are asked whether they are a teacher or a student. This makes it easier for the system to direct them to the right page. Each login and sign-up page also includes Wikipedia and Britannica dictionary buttons, so users can quickly access extra information related to Braille or accessibility. For teachers, the app provides a sign-up page where they can register using their username, email, and password. There's also a send OTP button for added security, ensuring that every account is verified and protected.
This is the teacher side of the app. This one is the landing page or the dashboard page. In here, it contains a message that fetches the username of the login user, the date today, and the time today. And there's a drop-down button here that contains logout button. Next one is the classes page. It contains the classes of the login professor. In here, there's a button where it contains a model that shows the students in the specific subject. In here, you can click the students here, and you can add feedback for that student. In here, there's a input type, activity number, score, and feedback. Upon typing here, it will be sent to the student that can be read by text to speech. In here, this is the main function of our system, the Braille translator. In Capture, it will open your camera, but I'm using an emulator now. That's why it's not showing the whole camera. But it can be used in the actual phone. Upon capturing, our machine learning will predict the outcome of that. Upon, the other button is the upload button. Here's the predicted result, and this is where it is processed. Next one is the feedback files. In here, you can see the activities that has been added in feedback. This is the one that I did earlier. In here, there's a crude functionality where you can update, delete, and play or pause the said activity. And that's it for that teacher page.
For students, it's even simpler. They don't need to sign up. Since their data is already stored in the system, they can just log in using their student ID to access.
In here, this is the student page. It only contains a logout button and a classroom list. This will display the comments from the teacher. As of now, there's no feedback available for this class. For this specific class, there's a button here that will show or will play the feedback from the prof. That's it for the student side.
Now, I will be discussing the landing page of our website. When users first visit Smart Vision website, they are welcomed with a simple and clean interface that contains three main sections: About, Technology, and Mission. These sections gives extra information about what our project or our website is, the technology behind it, and our goal to make learning more inclusive for the visually impaired. On this page, there's also a Get Started button that directs users to either log in or sign up. Both admins and teachers use the same login interface when visiting the website. For login, users simply enter their email and password, and for sign up, the required information includes their username, email, and password.
Now, I'll show you how the system works through different web pages of our platform. So here is the admin user interface, and here is the admin dashboard, which gives an overview of the system. From here, administrators can monitor system activity, user accounts, and recent actions. It serves as the control center for managing all of the modules. So the next is the user's web page. In this section, the admin can add new users, edit existing profiles, and manage user roles. This ensures that only authorized individuals can access specific parts of the system. Next is the student page, where we can import student data directly from the Excel files. The imported data is automatically transferred to, into the database table, saving time and reducing manual entry errors. It's an efficient way to manage large numbers of students and record at once. Next is the classroom page. Here, the admin can create new classroom, assign teacher, and add students to their respective classes. This setup improves accessibility since students are automatically linked to their teacher's classes, meaning they don't need to manually join anymore. It simplifies class organization and ensures all students are properly assigned. Finally, this is the audit trial page. It records all the actions made by the users in the system, such as adding, editing, or deleting data. This feature helps maintain transparency and accountability, allowing administrators to track every activity for security and data integrity. Good day everyone, I'm Radan Valiganyo and I will present results and discussion. For our machine learning model, we use YOLO model or you only look once. This model showed strong performance in both real-time and static braille detection, reaching an overall accuracy of 95%. In terms of evaluation, the model achieved high precision, meaning most detected braille dots were correctly identified, and a strong recall, which means it was able to detect most of the actual braille dots in the images. The mean average precision at 50% IOE confirmed that the model performs well in both detecting and accurately locating braille patterns. Overall, this result shows that YOLO is reliable and unified approach for recognizing braille across both live classroom interaction and static materials such as student assignments and works. Next, for the performance metrics, the model achieved an accuracy of 95% after several rounds of optimization and testing. Its processing speed averaged around 1.5 seconds per image, which makes it suitable for both real-time and offline use. In terms of research utilization, the system uses around 55 to 60% of CPU and less than 500 megabytes of memory, making it compatible with most mid-range devices and ensuring smooth performance during classroom use. For the impact of users, the system helps teachers efficiently interpret letter by letter braille submissions, making checking and grading much faster. For students, especially those using traditional braille boards, they can simply take a photo of their work and send it through messaging apps. This ensures that teachers receive their assignments even if students don't have access to digital devices, improving inclusivity and accessibility in the classroom.
Smart Vision successfully combines two machine learning models, YOLO for real-time braille detection and CV2CNN for static images, achieving 95% accuracy. This helps teachers interpret braille instantly, improving communication and making classroom learning more inclusive. The system supports the SPEDPASI curriculum, guiding students as they learn Braille from the basics while giving the teachers the ability to provide quick feedback with features like Braille recognition, text-to-speech, and file management. Smart Vision ensures accessibility, reliability, and efficiency for real classrooms. The panelists recommends expanding the Braille dataset to better support letter-by-letter learning. They also suggested optimizing the yellow model for real-time use under different lighting and angles. Another recommendation is to conduct more user testing with teachers and students to enhance usability. The panelists also advise improving the text-to-speech feature with more natural voice and customizable playback speeds. Finally, they recommend ensuring the system adapts well to modern Braille tools used in classrooms today.